here, and I'm going to take you through the steps of my technology project. The programming, the pseudocode, the technical drawing, and the building of the robot, and the final product, and also the testing. This is our robot, our NXT robot. It's a sumo wrestling robot. Basically, this is its weapon. It's small, sleek, designed wide so it can hit a good amount of the other opponent's robot. Here we have our kill switch. If it's hit, our robot shuts off completely. This is a big kill switch. Basically what it does is if it gets hit, it instantly turns around and smashes. Well, it's something behind it. Over here we have our wheels, our rubber traction wheels for good stopping and to get away basically. Here we have the color sensor that detects color, so it doesn't roll out the ring or get pushed out if it's facing the front. If it's being pushed out from the front backwards, then obviously because the color sensor at the front, nothing will be seen. No color will be seen by the color sensor. On the other side we have our ultrasonic sensor, which is what detects other robots for our weapon to move up and down. If anything's seen within a certain distance, it smashes and tries to hit the other person's kill switch. We have, let's see, 3 servos, which one controls the weapon, and the other 2 at the bottom control the wheels and movement. The wheels move separate ways to turn back and forth. Well, actually, it only turns right.
Okay, as you can see here, this is our first test trial with our robot. It's fighting another robot, which you'll see in a second. And our robot's able to complete our task and challenge and beat this robot. Although when tested with other robots, it was unable to defeat them, therefore calling for a change. This is what our robot looked like before we made our major changes. This is what the robot looks like after the changes, front, back, and side. One of our main reasons for the next change is because of something like this. Here we have our robot being flipped up from the bottom by something like a ramp. To avoid that, we put on a bottom guard to stop it ramps from lifting us up. Here we have our final product, our robot with our bumper, and here it is defeating our main nemesis.
Here are some sketches that I made with different designs, such as ramp, same thing over here, just more detailed technical writing. Ramp. Here is basically my design that we used, but with not everything that's on it. Side. This is a side side view, top view, and front view. It's hard to see, but front, top, side. Here is one with design with basically the same thing, but with the hammer on a different angle, giving it less range, which is why we never use this design. Here we have our latest design. Basically, no, this is our latest shovel design, which also was not used. Here's the design we used, our final design, with our little hammer. This is basically how you have it on the robot, and this is the bottom rack. Sensor, instead of having the sensor here, we moved it over here and put the color sensor on this side. Basically, and the kill switch is on this side. Actually, we have two kill switches, one on this side, one on this side, that do different things, as explained in the video.
This is our pseudocode. So in the beginning over here, we have the beginning bit that we do. It's when we face the robots opposite way to start in the ring. So this is the robot supposed to move to the edge, turn 180, pseudo means false, so this is written in language. And then we go forward and get into our alternative branch off we have here for the weapon. So even if the wheels or something is blocked, the weapon will keep on going. So it's ultrasonic, under 15 centimeters, so everything is centimeters. It rotates 166 degrees, brakes, then rotates 166 again, then brakes, and then rotates backwards 166, brakes, and then repeats. And for the false one, so if nothing's under 15 centimeters, it does absolutely nothing. Alright, so here we have our big loop that we have that the robot does endlessly. In the beginning, we have our color sensor, which is white out. So as soon as it sees that it's not on a white surface anymore, it goes to this, brakes, reverses X amount of time that we program it, and turns 180 degrees. Then if it's on white, then it goes to touch 1, which is in the pressed mode, and this is our kill switch, and it's in port 1. So if our kill switch is pressed, it's automatically power off. Then it goes down to our touch 2 if touch 1 is pressed, and if touch 2 is pressed, it'll basically turn 90 degrees and smack the other robot. This is a false kill switch we have on the robot, so if it's pressed, then our robot will turn around and attack the other robot, protecting our real kill switch. So 50-50 chance here. Then it goes down into our ultrasonic, back into our ultrasonic, and if it sees something, it'll within 15 centimeters, it'll go straight at it and start smacking it repeatedly. And if it doesn't see anything, then it'll go at a slight curve at 100% power. We did that so if we keep going straight, we might keep missing the robot, and if it's at a slight turn, then we have a slight advantage. So if we keep turning a little bit, then we have a more chance of catching the robot from its side or something like that.